This is work of both truth and fiction. Please use your brain to understand. We are low on budget. Frankly speaking, we don't have any budget. So don't go on every scene or frame. Similarity with Kubernetes technology is not a coincidence. I put a lot of effort to make that coincidence. This is just a funny interactive way to understand Kubernetes. So relax, learn and enjoy.
Today I am going to tell you a story. It's a story of progress, a never-ending, multi-generation, multi-star story. It's a story of a faraway, unknown world surrounded by an endless ocean called the Internet. There was a man with a crown. Not because he was from a royal family, he himself was powerful and has some unknown special skills. He was very popular among people around him. But what made him so powerful in the town? Why people were crazy about him and what he has done for them? This is an adventurous story of that. Very sorry to interrupt your story. Believe me, this interruption will be useful for you to enhance the experience of the movie, and you will soon find out why I presented Kubernetes as a movie. I am KAUSTUBH Sharma, AWS Certified Solution Architect and Developer, your multi-cloud DevOps guy. Welcome to the brand new series of Kubernetes. Do you know that Kubernetes has a relationship with an American science fiction TV series Star Trek? From there only I got the idea to make a movie on Kubernetes. This series is going to be a special and fun one as I have a good working experience on Kubernetes, and the best part is that as I am currently working on Kubernetes only, and it is a very hot topic in the industry right now, and I have worked on the Kubernetes in the production environment with all the major cloud service provider, whether it's AWS, Microsoft Azure or Google GCP. I have also included some personal tips in the videos from my experience, and I can make you sure that by the end of the topic you will have a complete understanding of the concepts explained in the video. Before we are going to learn Kubernetes, let me clear some doubts that why everybody needs to learn Kubernetes right now to stay relevant and earn more in the IT industry. Some of you may think like that, hey, I am a working professional from a Java background or a Linux background. Why should I learn Kubernetes? How it is going to help me to promote in my career? Or you may be a fresher who is from a CS or non-CS background. Why should I opt for a Kubernetes? These questions may come to your mind. So let me tell you that Kubernetes ecosystem involves many other technologies and aspects of the IT industry. Like you have to learn about operating systems like Linux, Windows, Android, etc. You have to learn about networking as it involves routing, services, ingress, egress. And if you are a fresher and if you are overwhelmed by these terms which I am saying, then don't worry. We are going to discuss all these terms in our upcoming tutorials. So even if you don't know anything about them, then also you are going to understand these videos. The security aspect is also there in form of firewall, RBAC, which application can be accessed by whom. Kubernetes also includes CI/CD, which we will use with Kubernetes to create automated and repeatable process to deploy applications. It also involves programming, and if you are afraid that, hey, I don't know how to code, then let me tell you that you don't need to be a skilled developer, but as you will be deploying actual applications, you have to troubleshoot them. So you just need to know the basics of any programming language like OOPS concepts, which you might have studied in your college, and you are good to go. And even if you don't know anything about them, then don't worry, we will learn all these whenever required in our upcoming tutorials. We are also going to learn about container runtimes, that is Docker, CRI-O, Containerd in detail. And we will also study the application architecture aspect as well. So by the end of the series, you will have a basic understanding of all aspects present in the IT industry. I researched a lot before making these videos, and you will learn Kubernetes from very scratch. We will start from very basic Kubernetes concepts like pods, nodes, services, ingress, cluster and all. And then we will move towards intermediate topics like how to practically use third-party tools like Prometheus, Grafana, OPA, ArgoCd. That's why I told in the starting of the movie that this is a multi-star film and there are going to be lots of cameo in it, and then we will learn about advanced concepts of Kubernetes like how to use service mesh, batch processing and machine learning with different third-party resources, and we will see all these in practical demos. So don't worry about that. So without any further delay, let's get started. But before we move towards this topic, we need to clear our fundamentals. So as I already told, this all going to be fun. So let's start our learning with some fun facts. So we start from very scratch, that what does the word Kubernetes mean? Kubernetes is a Greek word that refers to the helmsman or the captain of the ship. So if you see the movie which I made on the Kubernetes, by the way, if you haven't watched the movie till now, go out and watch it. You are going to love that. The link will be available in the description. So in the movie, Kubernetes is nothing but a ship captain. There will be many small things, but believe me, long back in one of my cloud and DevOps interviews, I was asked by the interviewer that what does Kubernetes means, and I have recited the whole definition of Kubernetes there and told about my previous work which I have done on Kubernetes. And she said, what does the word Kubernetes means? She said, you are working on this technology since a long time and you don't know what does it mean. This was the first question of that interview. Anyway, I got selected, but important thing is that, which I realized later, that it is a very good first question to ask. Even I asked same question after that when I interviewed someone, as it is a very basic question. And second, if you look from the interviewer's perspective, there could be two cases. Either you know it or you don't know it. So anyway, you are gone. So just thought it would be good for you to know. Kubernetes was originally designed by Google, which is now Alphabet, in mid 2014. But later in 2015, Google partnered with a non-profit tech organization, the Linux Foundation, to form CNCF, Cloud Native Computing Foundation, and offered Kubernetes as an open source technology. So Kubernetes is an open source, and you might have heard of many technologies and software that are open source. Does it mean they are free? Well, not necessary. Open source just means that its source code is available to the general public for use and modification from its original design. And depending on the license under which open source software is released, others may download it, modify it, and publish their version or fork back it to the community. And if the community approves, then they will merge your version into the original project and you will also become a contributor to that software. So even you can contribute to the Kubernetes development. I will provide a link to the Kubernetes source code in the description. In August 2018, Google announced that it was handing over all operational control of Kubernetes to the community. Since its creation, CNCF has launched a number of hosted sub-projects. It serves as a vendor-neutral home for many of the open source projects which are very fast growing, including Kubernetes, Prometheus, and Envoy. And as I said earlier as well, we are going to learn Prometheus as well. So some of you guys might be wondering why this guy is telling about these events. I want to learn Kubernetes practically. But if you look closely to all these events, you will observe that just 3-4 years back in the late 2018, Google handed over the Kubernetes operation control to community, and after which we are facing this COVID-19 period. According to some research, it roughly takes 10,000 hours to master something, which is around 8 to 10 years. So if you haven't heard of Kubernetes before this and starting from my videos, then don't worry. If you treat Kubernetes as a bus, then this bus may have arrived some years back, but this bus is still standing in front of you. So get onto the bus right now, start learning Kubernetes right now, don't miss this bus. So another popular name for Kubernetes is K8s, as there are exactly 8 characters in between the first and the last letter of the word Kubernetes. Google designed Kubernetes on the basis of decade-long experience with its internal cluster management system Borg and Omega. If you want to see their architecture as well, then I will attach their architecture with this video. You will be able to see the architecture right now on the screen. Borg name is derived from the Star Trek series and American science fiction series. Borg's ultimate goal is achieving perfection, and seems like Google's Borg is also achieving perfection by continuously evolving itself in the form of Kubernetes. The original code name for Kubernetes within Google was Project 7. Again a reference to the Star Trek X-Borg character 7 of 9. The 7 spoke on the wheel of the Kubernetes logo are a reference to that code name only. And if you have watched the movie carefully, our hero Kubernetes has a crown with exact 7 spokes in it, referencing the 7 spokes of the wheel in the Kubernetes logo. So Kubernetes itself is inspired by a movie character, so as a payback, I made a movie inspired by Kubernetes. If you haven't watched the Kubernetes movie till now, go out and watch it. You are going to definitely love that. The link will be available in the description. Kubernetes is an open source container orchestration platform. So there are these 3 words that we need to understand. What is open source? What is a container? And what is an orchestration platform? So we have already discussed the first question, that what is an open source. Now let's discuss what are the containers, and another question that arises with it is that why we need containers, why we actually need them. Applications and websites were present earlier as well, right? And they were running fine without Kubernetes or any other container technology. Then what led to the need for containers? So traditionally, organizations run applications on physical servers. Now maybe you have questions like that, what is a server? So server is basically nothing but a software or hardware device that accepts and responds to the requests made over a network. You can easily understand this by a very simple example. Suppose you opened any browser like Google Chrome or Edge and you go to any website. Suppose we go to www.google.com. So what your browser will do, as we have typed the Google URL, that is Uniform Resource Locator, it will make the request to the Google server. That is why URL is in general terms known as web address. So by this address google.com, Google has registered itself on the internet that hey, I am available on this address. So our browser will make a request to the Google server and Google server will respond back to our browser with its default homepage, which you were able to see in your browser. The device that makes the request and receives a response from the server, which in our case is our browser, is called a client. On the internet, the term server commonly refers to the computer system that receive requests for the web files and send those files to the client. So this is how our current internet works, and this model is popularly known as client-server architecture. So traditionally, when organizations used to run applications on physical servers, there was no way to define resources boundaries. Here resources mean CPU, RAM, etc. for applications in a physical server, and this caused resource allocation issues. For example, if multiple applications run on a physical server, there can be instances where one application would take up most of the resources. We can understand this by an example. Suppose we have a server on which multiple applications are hosted. One of the application is a shopping application, and due to festive sale, it start getting additional visitors or users in technical terms. So it start consuming more CPU, more RAM and more resources from the server. For example, it started consuming 80% of the resources, and as a result, other applications which are there on the server, which only require 30% of the resources, would underperform as there is no resources for them. A solution for this would be that we can run each application on a different physical server, right? But this did not scale. In simple words, scale means grow. In IT, we call it scale. So this method did not scale as resources were underutilized, which you can see in the diagram as well. And also it was very expensive for organization to maintain many physical servers. And for an organization, cost matters a lot. After security, it is the most important thing for an organization. Tell me in the comment section what is the least important thing for an organization. Don't say employees. So as a solution, virtualization was introduced. Virtualization is a process of creating a software-based or a virtual version of the computer with dedicated amounts of virtual CPU, virtual memory and virtual storage that are borrowed from an actual physical host computer, which can be your personal computer or a server in a cloud provider data center. Virtualization is an abstraction of a computer resources. So if you are unfamiliar with the term abstraction, then let me explain it to you that it is one of the OOPS or object-oriented programming concept, where abstraction is a process of hiding the implementation details from the users, or to the user only the functionality will be provided. In simple words, the user will have only the information on what that thing or object is, but they will be unaware of how it is doing that work. Or in simple words, hiding something. In IT, you can say it, we are abstracting something. I hope you are getting familiarity with the IT word and the IT concepts as well. So virtualization allows you to run multiple virtual machines, that is VM in shorts, on a single physical server resources. A virtual machine is a software construct that mimics the characteristics of a physical server. Or in simple words, a virtual machine is a computer file called a machine image or simply an image that behaves like an actual computer. It also allows our application to be isolated between VMs and provide a level of security, as the information of one application cannot be freely accessed by the another application. So suppose one application got hacked, it won't affect the other VMs as they are logically isolated from each other. Virtualization allows better utilization of resources in a physical server and also allows better scalability because an application can be added or updated easily and reduces our hardware costs and much more. And if you are unfamiliar with the terms scalability and other cloud terms like elasticity, agility and all, then I strictly suggest you to watch a live interaction with me and my friend where we discuss cloud computing and all these terms like scalability, elasticity and all from very scratch. The whole concept of cloud computing became popular after this concept of virtualization only. So big companies like Amazon, Microsoft, Google and many other cloud service provider, but these three are very big player in the cloud industry, came up with their cloud services. As Amazon came up with AWS, that is Amazon Web Service, Microsoft came with Microsoft Azure, Google came with GCP, Google Cloud Platform, and started offering these virtual machine as an infrastructure as a service or IaaS, where these virtual machines are offered with the different terminologies like Amazon EC2, that is Elastic Cloud Compute, or Azure VM, or Google GCE, that is Google Compute Engine. But all these services are just offering virtual machine to us on a pay-as-you-go pricing or consumption-based model. Or in simple terms, they are providing these virtual machine on rent. So this only concept is cloud computing, where they provide these different services like virtual machine over the internet with pay-as-you-go pricing, which means you only have to pay for what you are actually using. I have a detailed discussion video on this. You can check that out. I will provide the link in the description and here in the I button as well. And if you are wondering what is this hypervisor, then this is a software that creates and runs the virtual machines. A hypervisor, also known as VMM or virtual machine monitor, allows one host computer to support multiple guest VMs by virtually sharing its resources. It allows the host computer to support virtualization. So if everything went fine with virtualization and people are still using these services and cloud services are still providing these services on these, then why container concept came into picture? What was the need for the containers and what it is actually? So we will understand this by an example. So there are certain environments or stages in the application development process, like development environment, in which an application developer develops the application, and then application went to the testing environment, where the tester tests the application against multiple test cases and make sure that it will work under any condition. If tester found any bug or application fails under any condition or test, the tester will request back to the developer to resolve the bug, and developer will again send it back to the tester. And this process will continue till the application passes all the test cases. After that, some organizations have multiple other environment as well, like UAT, user acceptance testing environment, or pre-prod environment. But basically all these come under a testing stage only. After that, application goes to the real environment, or you can call it production environment, from where end users like us use the application. So let's come to our example. A developer develops an application and he tested himself first before sending it to the testing team, which all developers usually do, and the application works very fine. But the testing team rejects his version, saying that it is not working in their environment and does not pass all the test cases. So the same application which was working on one machine was not working on another. So developer research this and find out that what could be the reasons for this. So they come to know that application has some dependencies, or maybe it is compatible with certain versions or configurations, or it may require a certain framework to work. Or maybe it is an OS level dependencies, like we have certain applications that only work with Android. But on iOS or Windows, it may not work, as it has some specific dependency on Android operating system. Or maybe that application has some microservice dependency, which is available in developer system only, and not all the users will have the same system as developer, right? And they will not be using the same OS device, right? So that's where container deployment came into picture. What containers do? They actually provide a standard way to pack your application code with the dependencies and the configurations into a single package, and that package or container will run as a resource isolated process, ensuring quick, reliable and consistent deployments, and they will run regardless of environment or OS, which was the case in virtualization. Container runtime is software that is responsible for running containers. Some of the major container runtime examples are Docker Engine, Kubernetes Container Runtime, Containerd, CRI-O, etc. Out of these, Docker Engine is the most popular container runtime and one of the first platforms that came with the concept of containers, and widely used to create, deploy and run applications by using containers across multiple MNC organizations. Containers help us in creating and deploying applications in more agile ways, as they increase the ease and efficiency of container image creation compared to the VM image use. If you are unaware with these terms agility and scalability, elasticity, then I strictly suggest you to watch my cloud computing video first. The link will be available in the description and you can choose it from the I button as well. Containers also help in developing microservices architecture. So let's first visually understand the concept of microservices with an example. let's open AWS EC2 console, which I already told is a service from AWS to provision virtual machine. You can take example of any website or any application. So here you can see there are different services under EC2 console, like instances from where you can launch instance or virtual machine. And here you can see another AWS service, EBS or Elastic Block Storage, which is used to provide storage. So earlier we used to have monolithic application, means the whole application is developed as a single bundle and the full application is developed together. Means suppose this AWS website is launched as a monolithic application, then the code of the instance and the code of the EBS may interrupt each other. So both the team who are developing EBS and instances have to take care of each other dependencies. But sometimes there are dependencies which are required to function EBS. But if you include those dependencies, instance won't function at all. So with a monolith, changing or adding a single feature can disrupt the whole code for the entire application. This also makes upgrades a time-consuming and expensive process. The more upgrades you perform, the more complicated the programming will become, until the upgrades and scaling are virtually impossible. So to resolve these issues, microservice architecture came into picture, where developers choose to modularize the functionality of monolith into small independently running microservices. Modularize means dividing something into smaller components. This architecture offers greater agility and pluggability because enterprises can develop, deploy, and scale each microservices independently. They can do this without necessarily occurring service outages, without negatively impacting other parts of the application, and without needing to refactor other microservices. It also enables an organization to evolve its technology stack and organize around business capabilities. These microservices are highly maintainable and testable, as it enables rapid and frequent deployment and development. They are loosely coupled with other services via APIs to form a microservices-based application architecture, which enables a team to work independently the majority of time on their services without being impacted by the changes to the other services or without affecting other services. They are independently deployable, which means a team can deploy their services without having to coordinate with other teams. They are capable of being deployed by a small team, which is essential for high productivity by avoiding the high communication head of other large teams. All these benefits enable greater control on applications. Applications can be easily debugged, which result in increased productivity, and application updates will be released fast and more reliably. So containers also help in microservices architecture, where applications are broken into smaller independent pieces of loosely coupled, distributed, elastic, liberated microservices and can be deployed and managed dynamically, not like a monolithic stack running on a big single-purpose machine. Containers also provide reliable and frequent container image build and deployment with the quick and efficient rollbacks due to its image immutability, thus helping in CI/CD or continuous integration or continuous deployment. It also provides better observability, as containers will not only help you in observing surface level OS information and metrics, but also application health metrics and other signals. It also provides environmental consistency across all our environments like deployment, testing and production, means it will run the same as in our laptop as it does in the cloud. It provides you greater portability on different cloud platforms, and OS means it will run same on the Ubuntu, RHEL, Core OS, on-premises or all other major cloud service providers or anywhere else. Container also provide application-centric management. It also raises the level of abstraction from running an OS on virtual hardware to running an application on OS using logical resources, which means it removes the additional requirement of guest OS. Also, containers help in better resource isolation, as we can predict application performance metrics at a container level. Also, it helps in the better resource utilization. So as now we understand the concept of microservices and containers, let us understand why we need Kubernetes or any container orchestration tool in general. As organizations started moving from monolith to microservices, it caused the increased usage of container technologies, as container offers the perfect host for microservices-based application. And this increased usage of containers and microservices technologies result in applications that are comprised of hundreds or thousands of containers, and managing those thousands of containers across multiple environments using scripts and code made things very complex and tedious. This led to the need for having a proper way of managing these containers. that is container orchestration technologies like Kubernetes. So now we understand all these things. Let's continue our movie and revise it along with the movie. Also, let me know in the comment section which objects refers to what, which character is representing what. Just like in starting Kubernetes, we are a 7-spoke blue crown referred to the 7 spikes on the wheel of the Kubernetes logo, which is again is a reference to the project 7, which we already discussed. So put a comment with all characters representing what and all the references you find out, and I will soon release the movie along with the character's name as well, so you can then match how many characters references you got correct. So without any further delay, let's continue our movie.
There were 2 islands in this world, one in which God lives and on another normal humans live. There were no difference between gods and humans. They both take birth and die, they both have normal routines, they both have to work, they both go to the market, they both are very kind. They are very similar, except God has some superpowers of making good and tasty beverages. Beverages in this word means a lot. It's not a leisure thing here, it's like a food to them. They have to keep consuming beverages for their survival. But the problem is that only people from God Island know how to grow beverages plant and how to make them. Also, the people of God Island try to teach them how to make beverages by their own, but humans find it very complicated to make a beverage. Also, the land of Human Island was not that much fertile as of God Island, but gods were very kind to supply beverages to humans. There were different castes of God on God Island based on what work they do. One of them are developer gods. Their work was to make perfect beverages. Another one are tester gods, whose work was to taste beverages before sending beverages to humans. Once, a developer god made a special beverage. Developer god was so happy to make that tasty and healthy beverage. Following the normal procedure, it went to the tester god. But tester god rejected, saying that this is not healthy and had a very bad taste. Developer god became very angry and started fighting with the tester god. They both went to manager god to resolve their issue. Manager God listened to both and ordered Developer God to make the beverage again. Developer God again made that beverage, and this time he tested this beverage like 100 times before he gave it to manager. And once confirmed that this is the same tasty beverage that he made first, he gave it to the manager God. But even manager God doesn't found it tasteful. Developer God was shocked and he drank it again. It was tasteful for him. He insists manager God to drink from his glass once more. Manager God told him if he doesn't find this beverage tasty, he will fire him from the God community. Developer God accepted the offer. Manager God drinks it, and this time he found it very tasteful. According to him, this is the best beverage he ever had. Then they realized that beverage taste depend on the utensil in which they were drinking, like a gold utensil or silver or earthen pot. The combination of both utensils and ingredients make that beverage special. So now gods have the additional responsibility of supplying a combination of utensils and beverages to humans. Also, earlier, beverages used to contain only one ingredient, which they used to supply them in a small box. But with the time, God developed new varieties of beverages in which there were multiple ingredients required to make tasty and special beverages. So gods realized that they need something in which they can send the beverages along with the utensils. So they went to another demigod who worked as a docker, who can create, load and unload container from the ship. Demigod created a container for them. But now the issue arises how they will take these big containers to the human island. Docker suggested that he has a son named Swarm who can make a ship and take these containers to human. But God saw that Swarm was very ill and weak, so they didn't choose him for this work. They went to the royal palace and tell them about their issue that they need someone brave who can not only make a strong ship but also a brave driver of the ship. After hearing the issue, royals smiled and told them about their grandson, who was very patriotic, has done engineering and shipbuilding. Later he joined Navy as a captain. Not only he can make the ship, but also he can sail in the ocean between high tides and between the pirates and take it securely to the human island. His name is...
I hope you love the story. I know you did. That's why you are here till the end of the video. So make sure you hit that red subscribe button and press that bell icon. And don't worry, I will not make every video as a movie. So you will get the next Kubernetes video very soon. If you still think that how beverages become so important to someone, then ask from any chai or tea lover or any coffee lover. Tell me in the comment section that are you a coffee person or a tea person. If you want to know about my choice, basically I am not going to tell. Okay, I will not directly tell you that, but I can provide you a hint and you only have to guess it. The hint is that I am a proud Indian.